So when you calculate the rates of diffusion, you're actually calculating the speed of something. So a rate is a speed. If you're driving in a car, it'd be like, kilometers per hour or miles per hour. So rate is just an amount per hour. I actually have that written down right here. Rate is amount over a period of time. So in chemistry, we are actually probably, and this can vary, but we're talking probably about how many moles have moved or diffused or are moving over in a period of time. And this equation might look odd, this higher equation, but it's actually so simple. You take the rate of A, and on the bottom on the opposite side is the molar mass of A. That's that number from the chart. And then you take the rate of B, and the molar mass of B is over on that side. So basically, a problem could just give you this number, and you would know to look up here and here from the periodic chart, and then you can solve for that top number. So the equation, it might look kind of weird because it's got square root and stuff, but it's not a tricky equation. Let's give an example of how that equation might work. So N2 diffuses through a hole at a rate of this many moles per second. So here's my rate, and that's my rate of N2. If the same container contained argon, at what rate would it diffuse through the hole? And luckily, just to save time, you're going to have been given the molar masses of those two things. So we have one rate, and here is a pro tip to help a lot with this equation. Everyone will tend to take the number in the problem and put it here, but you don't want to do that. You want to make this your unknown. You'll notice it's just called like A and B, B and A. You can choose whatever you want to be in which spot. So choose what you don't know to be in this position, because it's a lot easier to solve for something in the numerator than something in the denominator, because you have to multiply it up and then you have to divide by the other part, and it's kind of a mess. So make your unknown the top thing. So we know the nitrogen's rate. What we don't know is the argon's rate. So we'll say the rate of argon is what we don't know over the rate of N2, which we do know. And we have our square root of, and it's going to be the molar mass of N2 over the molar mass of argon. So we just have 28.01 grams over 39.95. I'm going to move this below, and that's grams. Those are both grams per mole. And then this is what we don't know, rate of argon. And then what we do know is that the bottom number is 1.8 times 10 to the minus 7th moles, so that's an amount per second. And then I'm going to pull my calculator over, and I'll say I'm going to square root the right-hand side. So square root of 28.01 divided by 39.95. I'm going to step it outside of the, I'm just going to go ahead and push enter, but you can do it separately or together. And then that number times this one right here. So I'm going to multiply both sides by 1.8 times 10 to the minus 7th and 1.8 times 10 to the minus 7th. And this number will cancel with this number. So 1.8 e to the minus 7th. One 1.51 times 10 to the minus 7th. And the unit here is going to be the unit that you had before, moles per second. So my biggest tip with all of this is to set this up so that whatever you don't know is on top here. Sometimes these problems will give you two rates, and it will have you solve for a molar mass. In that case, set it up so that the molar mass of the unknown is on the top. I have one more kind of style of a problem. Sometimes instead of giving the rates, they'll say that I'm making up a new problem here, that the rate of argon, the rate of nitrogen is like 2 times faster than CO2. So in that case, you would just pick a number, because it doesn't really matter what number you pick. All they want to know is the ratio. So let's say the rate was 1 mole per second. So I'm just picking a random number of 1 mole per second. So nitrogen's is twice that. So if this is X, nitrogen's would be 2 moles per second. So that's the rate of nitrogen. And then this is the rate of CO2. And so that's the one that's just X. And of course I totally made it up, because it would be way faster than that much second for just a mole to move. And then the second part of it is going to be, since I picked this to be nitrogen up here, I would put the molar mass of N2 here, and then the molar mass of, I should have said this slightly differently. I should have said then what gas. That's what I had meant to do. I was thinking ahead when I said CO2. So I set this up so that my unknown was this top number. And then when you do the math, you would end up saying 2 is equal to the square root of X over 28.02. And then I would square both sides. So I get 4 is equal to X over 28.02. And then I cross multiply it up. So those cancel, and I get the 28.2 times 4, which gives me X equals 112 grams per mole. And then I would have to either go searching on the chart, or it would give me maybe some answer choices, and I would pick the one that has this molar mass. So hopefully that makes sense, and using these aren't too much of a worry for you.